Everyone, in this video I'll be going over the steps for creating a parametric vase form, and I've been getting into 3D printing, so this is something that I just wanted to create to create some interesting shapes and then be able to produce them with the 3D printer. So I'll be going over from the beginning initial design stage all the way down to the manufacturing and production of the design. So let me show you what it takes to kind of get some of this done. So to create this shape that I was talking about, I'm gonna go ahead and open Grasshopper here, and I'm gonna start with basic forms. So I'm gonna use a circle to be able to create that shape, and I'm also in millimeters because that's what the 3D printer that's the units that it looks at. So let's see, I'm gonna be, let's go with the 50 millimeter radius here. And so we're creating the base geometry, which I'm using a circle. So now that we have the base circle, we want to we want to create a form that kind of weaves in and out. And so we're gonna move this, we're gonna move it up. So we have that initial shape, and we can move this up in the Z direction. We can go, let's say, another 50, so the same amount. And so we have that shape and this shape. Now I'm gonna hide this shape because I want to offset that shape. I want to offset it out a certain amount, let's say 20, but I want it to offset out. So the reason why I do this is because I don't ever want the circle to go in. I only want it to go out. So I'll make it a max of let's say 30, and so it'll only allow me to go out. And so that's what I want. I want that initial shape and that form that goes out. And so now we can move on and create another shape, which instead of creating another shape, what I'm going to do is I'm going to take this circle and I'm going to put a circle of the same size right above by mirroring this geometry and using this circle plane as the mirror plane. And so we have that first, second, and third shape, which we could now loft together and create an interesting form. But we want that top lip to be able to offset out also. So let me show you here. Let's offset this one. Let's move that one up. Move this shape up. So we can move that up a certain amount and then offset it out. Could also increase that height here, so we can go to 50. We can increase or decrease, and then we can change that form. We could easily lock this together. Starting with the first one here, moving on to this one, flattening it. So that we have the initial form that we're going to use for creating the vase form. So there we have that. We can move this up and down and stretch the height there, and then also the offset of the middle. Okay, so here we have the form. That's the final form, and we've created it by offsetting circles and using the circles as mirror planes. And so there we have the form. Now what we want to do is create a solid offset for the surface, and we want to poke a bunch of holes through it so we can, you know, create an interesting form. And so, okay, let's get that done. Offset it a certain amount. So let's say 5 millimeters thick. So it starts offsetting to the inside. Now you could either try to offset in or offset out, either way. So we have that offset surface and we have that inner surface, and as you can see, they are both, the one that is inside is, you know, off the ground, and then here it clips that one. So what we're gonna do is hide both of these by unpreviewing them, and let's also hide all of this other initial stuff. And what we're gonna do is we're gonna cap them, both of them. So you go to cap holes, and so you'll see here, when you do that, it creates the top and the bottom, and then you create that one into a solid. You have one inside of the other. Now let's go ahead and hide both of those, and we can see that this bottom one is the outside and the top one is the inside. So let's subtract. So Boolean difference, which here it's called subtract, solid subtraction, solid difference, and we know the bottom one is the outside one and this is going to be the inside one. And so there we go, we have a vase, I guess, a vase, and that's the form that we have successfully created, which we can, you know, this we can straight 3D print if we wanted to right now, because it's a solid. It has enough and it has enough of an angle that it won't need supports. And so as you can see, we can adjust, you know, the height. We can adjust the design of it here. Now what's interesting is that this form, since it's created with, you know, on a surface that the lip goes out, and that's why I offset out, because if you offset in, all of a sudden that inside, this inside form won't be outside, it'll actually be inside. So that's why you need this form, this lip, to be out, and so that's what we have here. That lip can only go out, or it can only go in, and when it's in, you can see that it can still clip it. But if we go the opposite, if we go negative, it won't work. See what I mean? It can only be offset out. So let's go to 0 here, and if we have it at 0, that surface, it's gonna clip enough. So that is the reason why I use the circles and I offset out. It's because this form in particular will allow you to offset in, cap it, and create that solid. Same with the bottom here. If we had the bottom circle, the bottom radius go out further, it would create a hole at the bottom. So there we have the form, and this is not just You know, this is not just for creating, you know, a vase. It could also be used to create an architectural form, like a skin on a building. Alright, so now that we have the form, I'm going to be doing a voiceover in this portion because I didn't record the audio before, but what you're going to want to do is basically subdivide the surface, because we do want to create some perforations like you saw at the beginning of the video. And so the way that I wanted to do it was to offset the initial lofted surface, and so by making it into a, let's see, by offsetting it and using it as a negative, you're able to offset out from that initial surface. And so I was thinking offsetting it out and offsetting it back in to use those surface frames and create the, you know, the forms and then loft them together. But later on I decided to, you know, I changed my mind and decided to do something different. So in the end, I'm not going to be using both of these surfaces. I'm only going to be using one of the surfaces and using those to extrude out of. So as you can see, I used this component called surface frames, and you should be able to find it. What I do is I plugged in those offsetted surfaces from the initial surface. I offsetted it out and then I subdivided it using that surface frames. So what it does is it creates planes perpendicular to, you know, to the surface, depending on the subdivision U and D. Okay, so in this portion, I just hit that surface, and I was gonna use, you know, those frames to create those polygons, and I was gonna loft them together, but I wasn't able to. It for some reason, when I took one set and put in the other set, I thought it would work. I thought it would connect them. I tried flattening it, I tried grafting it, and it just didn't work. So my next approach was to extrude one of those polygons, and I figured out a way to do it, which I hadn't tried before. I hadn't, you know, used before, but it somehow seemed to work. So as you see here, I just tried so many different ways. I tried all the different options. So as you see, I just gave up on that and I just decided to extrude one of the sets, and then I just used, you know, the amplitude and the frame, hoping that it would, you know, it would extrude in the same direction, and it didn't work until I flattened it, and somehow I was able to fix the issue, which now it's extruding in the direction of each one of those planes. So as you can see, I'm only using one set of surfaces. I'm not using both of them. So I can delete that one, but I didn't at that point. So as you can see, I also, when you extrude something, you have to cap it if you're gonna do a difference. So that was the approach that I took for creating basically the geometry around the shape, so then I could, you know, subtract it. And here I am kind of cleaning it up a little bit and messing around with the different parameters that I created for these other polygon shapes. And so there we have that solid, and those are going to be the perforations. And so here I'm going to just mess around with those parameters there. And now I'm using a different slider for the V, just so I can get more divisions going the other way and decrease the number of divisions in the vertical direction, which is U. And now, right now I'm using just a square, which when it's put kind of in a diamond position, but that could be changed into a triangle. It could be used. It could be changed into a, pentagon, a hexagon, octagon, and it's going to produce a different result every time. So that's what I think is useful about this tool, is you can kind of mess around with the geometry just by pulling a little slider, and come up with things that you wouldn't have come up with otherwise. So it's just an interesting way of designing and producing interesting shapes. Now at this point I'm just going to take, I'm going to do the Boolean difference, so I'm going to subtract from that initial form those squares. And without even needing to flatten it or anything, it gave us a cool result. Here I'm changing the, I'm increasing the number of divisions, so it creates a more even pattern. But it's it's a bit heavy because you are subtracting a lot of objects. And here we're decreasing the size so they don't clip all the way. And now I'm creating a fillet on the polygon, which actually creates an even nicer form, I think. So we can increase now the size of that polygon, and then now we have an interesting form. I'm going to go ahead and also increase the number of divisions more in the vertical direction, and so now we have that. Now since we have the basic form, I wanted to create a like a top ring or a little lip at the top. And to be able to do that, we're gonna have to move, or we're gonna have to extrude you know, the top ring that we see there, and we're gonna offset it and create that top lip. So what I did was I deconstructed that solid that we had, and I chose the one of the items which what I did here was I took one of the items from that shape, and the item that I chose was the top ring, and so that ring I used the outside edges to offset out and create that top lip, as you see here. So we have those edges that we chose, which are basically the two curves you see there. And so I'm offsetting both of those the same amount in and out. At this point, what I usually do is I take those two curves and I extrude them, I cap them, and then I subtract them. The outside ring, or I subtract the inside ring from the outside ring to create a solid. So that's what I'm doing here. I'm creating those steps before I even plug in the initial curves, because I've done this multiple times before, and so you know, I kind of skip some steps. So what you see is I'm extruding it a certain amount, which is in the Z direction, and we do the outside one, the inside one, and if we hide that, we have the resulting solid, which gives us the top ring, the bottom ring, or the bottom form. Now we still have some holes at the bottom, which is not something that is ideal, or not something that I want. So I am gonna go over the steps of how I created not just the top ring, but a base that, you know, blends in with the form. And so at this point, this is since I'm going to be 3D printing it, it has to be a watertight solid. So I'm using a solid union, a Boolean union right here, flattening it just to you know, have that whole thing completely solid. So I'm going to deactivate it for now, and I'm just going to preview the two forms that we have. So as you can see, we have that initial curve which started the whole thing, and that's what we're gonna have to, or what we want to extrude. And the amount that we want to extrude it is the same amount of the thickness that we offset that surface. So whatever thickness we have, that's what I wanted to use. And so here I'm trying to look for it, and I think the offset, see, that's a surface I didn't need, and so I deleted it there. But what I'm looking for is that number for the bottom. You know, sometimes it takes me a while to go back and trace back the things if I don't label them right away. So there, I found it. It's a 5, and then I plug it into there, so whenever I change the thickness, it'll give me that same amount at the bottom. But as you can see, I still have the holes there. It doesn't
fully enclose the bottom. And so I'm also taking that initial circle and I'm offsetting it out. This was a little bit too much, but I'm offsetting it out and plugging it back into that extrusion that I had there. That way I can control, you know, if I want the base to be a little bit wider than the bottom, and since I'm going to be putting it all together, it's not going to matter right now if it intersects the other part. And so I have it offsetting out too, but I do want it, I want to be able to increase the base depending on, you know, I want to add more to the thickness. So I thought that I could just have it an independent slider for that, but a better decision was to add the initial thickness plus a specific number, which I will show, and that be the way that I can control the bottom part of the geometry. So I went back to the 5 there. And no, it's still not working. I'm trying to see if by not offsetting it works. But now I'm gonna go ahead and do the see, now I'm putting it all together and it still has a hole at the bottom, which is not something I want. I just want to make sure that the bottom has a complete solid, even though it has perforations on the outside. Just in case you put a pencil there or something, I don't want it to slip out, so I'm offsetting it out more to see if it helps. And it still has a hole at the bottom. So now I'm gonna plug that in there, and I'm gonna add that initial 5 thickness that we have for the walls. I'm gonna copy that slider, and so I'm gonna add a certain amount to that too. So whatever that was, it adds 1. And it is a bit heavy, like I said, because we're working with the solid and we're doing a lot of different calculations at the same time. And so now it's completely enclosed, and this is, you know, what I was looking for. And so this should be a good enough form to 3D print. So we've successfully created that. I will make sure to clean up and have all of this organized for you to download and mess around with. I'm sorry this was kind of like a longer and more a little bit more boring than normal, but sometimes when I do a voiceover I forget exactly the steps that I took for creating it, and so watching it and doing the voiceover at the same time, it's a bit tricky. So I apologize for some of those mess ups, but as you can see, we have that form, and I'm pretty happy with it. I know I can find I can do a lot more, you know, forms, but you know, I just stuck with this initial one that I made. I mean, I could have varied them a lot. So maybe in another video I'll create like all the variations that you can make on something like this, but for now I just created a rendering scene, and I am doing it on a time lapse, and showing you, I just used some random pre-made colors, and I put a sky and a shiny ground and got a pretty interesting result in the end. So I hope you enjoyed the tutorial and learned something, because I sure didn't know some of these things, and somehow they worked out. So hopefully it inspires you to do some more parametric design, because it's a lot of fun, and I feel like it's such an interesting way of designing that I'm pretty much obsessed with it. So thank you very much for watching, and stay tuned for more videos.